Hey there folks, welcome back to Advent of Code 2023, where we're being dumb and using Microsoft Visual Basic 1. Last time was the struggle. Hopefully we'll be able to knock day 2 out of the park here. So we're having some really big issues, and I think I may know what the problem is. Some people in the comments actually pointed me in a direction which I think is good. I think I'm missing a loop. We have one do which loops through all of the games, each line. This do loops through all of the picks, so everything in between semicolons. So like 3 blue, 4 red, and then we need to go 1 red, 1 green, 6 blue, and so on and so forth. So we have 3 loops that we're doing. The line, in between the semicolons, and in between the commas. And I only have 2 do's at this point in time. So there's clearly something wrong there. So when I split on the semicolon, then I have to also we're splitting on the comma. We need another do here. So we are looping. We're doing this until the end of the line. Here we're looping until the current line is evaporated, which makes no sense if we miss a loop. So let's put in another loop. Now, where are we going to put in this loop? We split on the semicolon, then we get the number and the color by splitting on the comma, pick string. So pick string is going to be what's left. So we need a do loop until pick string is empty. So I think our do is going to be here. We're going to do this, and we're going to say loop until. Now we need pick string. The length of pick string equals 0. I think that's going to do it for us. So hopefully this fixes everything. So let's see what we got here. How do I? Here we go. So calculate. So we're going to delete all this. We're going to put a breakpoint. Let's put a breakpoint here. That's a good place for a breakpoint. Okay, so actually, let's put the breakpoint here. This is our new breakpoint. Okay, so we're going to print out print amount. Now, can I do a comma? Color string, 3 blue. So is that right? Is the first thing we got 3 blue? Yes, yes it is. Now I'm looking for 4 red. So let's hit F5 and let's print out our 4 red. Perfect. And now we will go again. And this time, what are we looking for? We're looking for 1 red. 1 red. I think we got this. Okay, and so that's just going to continue. So let's get rid of the breakpoint here. This looks like a breakpoint I don't want. And we'll just continue this. And it says not possible. What the heck? Not possible. I was expecting a number, thank you very much. Oh, right. Because last time we did a whole bunch of weirdo stuff. Oh, right, because I have an exit sub. Okay, I have to figure out what the heck I did last time. If possible, Possible being -1 means it's not possible. So this is real. This is fake. There we go. So if it's not, so if it is possible, right, because -1 means it's not possible. So it's bigger than -1 means it's possible. The game is possible. Then that's going to be, we're going to add to the sum of possible games. And so what is the answer I'm expecting? 8. You get 8. Because 1, 2, and 5 are possible. Okay, let's do this. And run this. 8. Excellent. Perfect. Now we're going to load in our actual test. Now, what is our test? I can't remember. It's been a couple of days, folks. I think it would be input 1. Yeah. Look at all these games. Holy crow. How many of them are there? There's 100 games. Okay. So this is input 01 txt. Whoops. Okay, input 01.txt. Give me a number. Illegal function call. Because I hit the test button. Oh my word, I kept that in there. Why did I hit the test button? Input 01.txt. Calculate 2,879. All right, then let's go over to my real computer and plug this in. Here we are. 2879. Submit. We did it. We did it. Okay, continue to part 2. The elf says they've stopped producing snow because they aren't getting any water. He isn't sure why the water stopped. However, he can show you how to get to the water source to check it out for yourself. It's just up ahead. As you continue your walk, the elf poses a second question. In each game you've played, what is the fewest number of cubes of each color that could have been in the bag to make the game possible? Okay. Again, consider these. Okay, so in game 1, the game could have been played with as few as 4 red, 2 green, and 6 blue. If any color had even 1 fewer cube, the game would have been impossible. Okay, so you're just looking for the biggest of each color. Game 3 must have been played with at least 20. Okay, well, that's not entirely difficult. It is not quite the second part that I thought. Game 5 needed nowhere fewer than 6 red, 3 green, and 2 blue. Okay. The power of a set of cubes is equal to the numbers of red, green, and blue cubes multiplied together. So the power of the minimum set of cubes in game 1 is 48. Interesting. Okay. 6 times, so I'm looking for game like 4. 14 times 15 is 190, 210, 630. Yeah. Okay. So game 3, it's 20 times 13 times 6, which is 120 times 13, which is 1440. 1560. Yeah, that's right. Okay, well, that's fairly simple. For each game, find the minimum set of cubes that must have been present. What is the sum of the power of these sets? All right, so we got to keep track of maximums. So let's do this. Let's bring the real computer back up. Okay, and we will do this. So we've got to each pick, which is, again, let's look at our picks. So our picks are between the semicolons. So we just got to look for the biggest, keep track of the colors with the most value in each game. So here we're going to look at 3 blue and 4 red, and then the next pick, oh, there's 6 blue, so we're going to have to update our maximum blue count. Okay, it doesn't seem that difficult. So let's see if we've written this code in a way that can be easily extended. So right now we're finding out the color of the number of red in this current pick and just checking to see if it's less than the actual amount of balls. So now, instead of checking it against an actual amount, we're going to have to keep track to see if it's the maximum. So the maximum is going to come every time we do the first loop, right? This is the first loop. So when we start a new game, which is here, we're going to be resetting our max. So max or min, it's our minimum, right? So min red will be 0, min blue will be 0, and min green will be 0. Okay, we're going to get our color. Now if it's red, now remember, amount is the amount of red that is in the pick. So instead of, we're going to have to say if amount is greater than the min red, then min red, oops, is equal to amount. We need at least that much red to play this game. And the others are just going to follow suit. This is not too difficult. So if the amount of green is greater than the current minimum green, then min green equals amount. And similarly with blue. Now we probably could have written this a little nicer. Min blue equals amount. Every time we're checking for, actually, yeah. No, I don't want to spend time making that more efficient with less code. Actually, I don't even think you can. Nothing actually is coming to mind. Whatever. Who really gives a crap? Because this is 1991. I think even in 2023, no one would give a crap. Okay. That's it. Okay, so now we have our min red, min green, and min blue. And once we come out of it, we are going to do that because we're no longer talking about possibilities. We're just talking about the actual number of cubes. So we're just going to loop until the line is exhausted. And now we have our min red, min blue, and min green. So we're going to say, what did they call us? The power equals min red times, min blue times min green. And now we don't have anything possible anymore. Now we do have this sum variable, which is currently called sum of possible games. What is this? This is now called sum of power. Sum of powers is 0. Whoops. Jumping all over the place. So this, sum of powers plus power. Oh man. And here, this becomes sum of power. Am I still using the same input? I think so. Okay. This looks perfect. Let's get rid of some of these empty lines here. This can go like that. And I think this totally makes sense. Amount is greater than min red, min green, min blue. See, the problem with Visual Basic and kind of all basics, I think, although my experience does not stretch back beyond QBasic. I did a little bit with GW Basic, but I didn't even know what it was, so I don't count that. When you don't declare a variable, it just defaults to like 0 for an integer, an empty string, or something like that. So if you misspell a variable, then you're screwed. It's kind of like you'll have a mysterious 0 somewhere. Okay, I think this is good. Let's do it. Let's see what we get here. Let us run this. This is input01.txt. Calculate. That's not good. I'm gonna come out right now and say that's not good. What in the heck is that all about? And see, that was perfect. I misspelt this. It's sum of powers. Perfect. Couldn't have happened any better than that. I promise you I did not plan that. Okay. What? What? Sum of powers. What? Uh-huh. Wait a second. What? No, that's not real. What is going on? Okay. Come on. Okay, let's put a breakpoint here. Actually, let's run this from the test input itself. So we have our test input. Okay, so where's this lovely thing? Okay. What is min red and min blue and min green? 4, 0, and 2. So for the first game, is it really the case that you didn't need any blue? And I'm going to say no, you needed 3 blue. You needed 6 blue. You needed blue. What? Ah. Wow. There it is. Goodness me. So here's the problem. I'm checking for amount less than min blue. Now here's something interesting. Min blue, So amount is never less than 0 because it starts off, let me do this, min blue will always start off each game as 0. This will never be true. Min blue will stay at 0, which makes this product always 0, which makes this always 0. And so if I change this to what it was supposed to be in the first place, we can run this. Oh, right. Let's get rid of that. So 2286, is that? Yeah, that's what we needed. That's what we needed. We needed to see 2286. Okay, so that was our test input. Now let's run it with our actual input. I'm a little scared for like overflowing past the 32,000, but we'll check. Yeah, overflow. So in order to fix that, sum of powers needs to be along. Yes, I do want to restart my program. Thank you so much. Okay, sum of powers is now along. Okay, let's run this again. Change this. $65,120. Okay. Here we go. 65,120. Submit. What? No! What? See, I had this test data all right. This came out to 2,286, so why the heck does this not work? Interesting. Okay, let's go back here and figure out what in the heck, whoops, what in the heck just happened. Now, maybe, did I run this straight from a fresh run? Yeah, it's totally there. 65,122. Okay, you know what? Oops. See, a long, that is a long, right? Where's my help file? Why isn't F1 working? Oh, maybe because I'm running? Right, okay. Long. Yeah, so this is good up to 2 billion. And it is specified with an ampersand. I don't think I'm going to fix my issue. Huh. Well, see, the thing is, what happens when you go 3 integers? Okay, we're going to have to figure this out here. What I want to do, because I want to make sure we're not overflowing. So here's my test, and we're just gonna hard code some tests in here. So we're gonna say A equals, let's say 30,000. We can do that. And B is an integer, and that's 5. Okay, and now C is going to be a long, and it's going to be that integer times that integer. And then we're going to put the answer into output. And I want to see that answer be 150,000. And if it's not, then I got a pretty good idea what the issue is. Identifier is not an object because I misspelled that. Thank you very much. Start. Test. Overflow. But see, C is a long. And so, yeah. Stupid. Yes, I really, really, really super want to restart my freaking program. Okay. I mean, this should work because everything's long. What's going on? Oh, peace. I want to cry. Oh, B7. Oh my word. What? Why isn't my keyboard working? Oh, because it's stupid thing. Okay. Start. Test. This is stupid. 150,000. Oh. Okay, everything's long. I still don't understand why. Oh, no, I'm not in the form. I still don't understand if we were getting overflow. Shoot, did it say it was too low? I think it said it was too low. Yeah, we need to go higher. I was just trying to think all of this stuff with overflow. If the website had said, "Oh, you're wrong, it's too high," then all of this is pointless. But no, I'm pretty sure it said low. I'm second guessing myself every 30 seconds here. Okay, so I just don't understand. See, power. I wonder if power. Could we just make power a long? I kind of think we need to make everything a long. No, these all have to be longs too, because we were getting overflows. Okay, we're just making everything a long. Everything gets to be a long. You get to be a long. And you get to be a long. Oh my word, is there a replace? I think I already looked up this thing. Oh, there is a replace. Can I say just current procedure? Excellent. All the percents. Well, here, let's go min blue percent. I still do have, oh, for crying out loud, this is stupid. It's probably simpler just to do this. I do have variables I want to keep as integers. That's very interesting behavior, though. Oh, I changed them out. Oh, everything's, oh my word. Holy crap. Okay, I gotta focus here. Amounts don't change to percentages, but everything else does. I'd like to investigate that casting. That's really quite fascinating. Possible and stuff. That's from previous. That doesn't matter. Okay. Duplicate definition. Right. Okay. Run. Start. Okay. Input 0, 1, calculate. See, I'm still getting 65,122. What? We just stumbled upon the right answer. What did we have before? What? Okay, yay! What just happened? What did I try before? What the heck is going on? What? Okay, I'll have to go back and check the video, but yay, we did it! Goodness me. Now I want to do some tests. I think it's important that that we do some tests here. Because so this is it. We're not doing anything else today. We finished day 2, and now I just want to make sure that okay, these are both integers. So let's take 16,000 and multiply it by 2. And these are both integers. And C is a long. And this goes like this. Let's go temp equals that. This is the long, this is the answer. We'll just, yeah, answer's fine, whatever. Answer equals 0. I want to go answer equals answer plus temp. So that's going to make it go up to 32,000. And then I'm going to say, we're very close to the edge. So now we'll just say answer equals answer plus temp again. We'll just do it twice, and then we'll do this. So answer is going to first be 32,000, then it should be 64,000, and everything should work out. And this should, I'm really quite fascinated by how this. All right, maybe the bigger conundrum. Man, I've stumbled upon success here, and I don't know why. Well, I'm going to have to look back at the video. Maybe I punched it in incorrectly before, but that overflow doesn't seem to be, like, we seem to be able to, I wonder if, I guess we can try this. Since temp is, okay, let's just do A plus A plus A. So A is 16,000, answer is now 48,000, which is outside the bounds of an integer, but it fits into a long. Let's try this. Start, test, overflow. See, we're getting an overflow exception. We weren't getting an overflow exception. Okay, I should just be grateful we did it. Anyway, that's fantastic. Thanks for joining me today. If you are interested in really old code like this, and you want to see me laugh and cry, I have a series of videos I've done over the years called Adventures in Old Code, and you can check it out. You can see the card on the screen now. Some of the early ones suck. Some of the later ones are funny. It's basically just old code that me or my brother wrote. You can have a good laugh while you see it, what came out of our brains back in the day. So that's a plug for my other videos. Yeah. Okay, we successfully finished day 2. Well, thanks for joining me. Have a nice day, and we will see you next time.